It took nature over 30 million years to recover from the largest biospheric catastrophe on the planet, called the Great Triassic extinction. When life began to develop again, completely different animals started to prevail, who ruled the planet for the next 160 million years. They lend their name to an entire era in the development of our planet. They started their triumphant journey to the pinnacle of evolution as small creatures with bird tracks. Thanks to their great adaptability, they managed to edge out all the big predators. The first dinosaurs on Earth. These reptiles appeared in the Mesozoic era, otherwise known as the dinosaur era. Their first remains were found in the Triassic period that started almost 250 million years ago, and lasted 51 million years. In the Triassic period, the Earth was quite different from what it is today. The land was represented by a single supercontinent of Pangaea, surrounded by the waters of the Pangaea's mega ocean. The face of Pangaea was constantly changing. Inland water bodies appeared and disappeared and mountains formed. It was during this period that the Ural Range was formed. At the start of the Mesozoic era, the planet became warmer. The temperature probably rose due to the large amount of carbon dioxide that formed as a result of numerous volcanic eruptions caused by tectonic plate movement. Calculations prove that 100,000 gigatons of CO2 were emitted into the atmosphere in that period. It is a well-known fact that this gas creates greenhouse effect. The solar rays enter the Earth's atmosphere and reach its surface as short-frequency waves. The planet heats up and begins to emit longer wavelengths of heat radiation. Some of them must go into space, but greenhouse gases don't let waves of this wavelength slip away, especially CO2. As a result, this makes the planet's temperature rise. During the Triassic period, the snow caps at the poles melted due to global warming. The climate has become less zonal, making it more homogeneous throughout the whole Pangaea. The rainy season lasted only 3 months a year. 9 months of drought followed. Then the water bodies became shallow and evaporated, drying up almost all vegetation. The supercontinent was covered mostly by barren deserts. It was very difficult for life to recover after the mass extinction under such conditions. Life continued to evolve mainly on the banks of water bodies and nearby. The plants in these green oases have changed a lot. Droughts have completely destroyed tree-like, club moss and many spore fern species. The coniferous trees of the Permian period also disappeared and were quickly replaced by new plant species that were more adapted to dry habitats. Thuggea and Alocaria emerged and have survived to this day. Some conifers of that time were herbs without hardwood stems. This allowed the plants to recover faster with the onset of the rainy season. Also, cycads and ginkgo and other gymnosperas, similar to modern palm trees, began to spread throughout the supercontinent. However, seed ferns continued to dominate. Many insects flew and crawled among these plants. Crickets, beetles, exotic cockroaches with large furry paws preferred to suck plant sap or feed on pollen. But predatory insect larvae often devoured their own kind. For example, gelatinous baby snout beetles waited for prey in cyad cones. Dragonflies were flying over water bodies catching insects, and 40-centimeter mesosticandids with serrated sickle-shaped paws have gone as far as hunting small amphibians. Sharks and bony fish were fighting for prey in the open sea. Over time, they developed jaws that could easily crush crab shells and seashells. But wraith and fish wasn't lacking behind. Like the modern pike, these predators were over 1 meter long. The newly emerged aquatic reptiles called Notosaurus were the largest hunters of the Triassic seas. Similar to giant dinosaurs, Notosaurus fished with their sharp teeth. They swam very fast and could catch up with any prey. The number of amphibians that once dominated other animals on land continued to decline, even though some species were still quite numerous. Labyrinthodonts lived in swamps, lakes, and rivers across all continents. They resembled both frogs in crocodiles and had horizontal hips and shoulders. Their length ranged from 0.5 meter to 5 meters. Labyrinthodonts were carnivores who preyed on their relatives and small fish using ambush techniques. These green-gray animals blended perfectly with the environment, waiting for hours with their mouths open. Their jaws would slam shut whenever someone came close enough for them to reach and crush the prey with their formidable teeth. Labyrinthodonts defended themselves from enemies with the firm, shelled bone plates covering their entire bodies. As in the Permian period, numerous reptiles dominated the planet. However, they changed a lot during the Triassic period. The most advanced forms of reptiles weren't affected by the Great Extinction. The distant ancestors of mammals called cynodonts were among these animals. These small creatures weren't bigger than a weasel or, more rarely, a large dog. They literally had to survive under the feet of large predators. But cynodonts knew how to dig deep burrows and often lived in pairs, caring for their young. It is hypothesized that some of them have already fed milk to their offspring. Some of these animals might have been marsupials and carried their young on them. Moreover, furry, warm-blooded cynodonts didn't have to warm up in the morning. They could easily hunt at night when large predators were asleep. Having adapted to the new conditions, these reptiles spread across the whole planet. And the super predators were mostly represented by crocodiles, or rather their 8-meter crocodile morph ancestors. These reptiles' huge teeth, ferocity, and strength terrified the animals of the Triassic world. One particular species of crocodile morphs was given a no less terrifying name, the Carolina butcher, or Carnifex carolinus. Visually, this 3-meter predator resembled a large crocodile. However, it preferred to live on land rather than in water and could quickly run on its hind legs. The ancestors of modern crocodiles had extremely sharp teeth. They could bite through thick reptilian shells. Finally, the first dinosaurs emerged in the middle of the Triassic period. Paleontologists find their bones all over the world, predominantly in modern Argentina. At first, these reptiles weren't giants, but they grew larger over time. But what helped dinosaurs to survive in the world of predators of the Triassic and evolve so quickly? First of all, many of them were bipedal. Interestingly, the reptiles stepped on their toes, just like birds, and not on their heels like us. This is why the traces of these small animals resemble heron tracks. Dinosaurs' legs were under their abdomen, as opposed to on either side of the body, like in crocodiles, for example. Because of this, these reptiles could quickly catch up with the prey or run away from the predator. In addition, dinosaurs were inertial homeotherms, meaning that their body warmed up a lot during the day, but it didn't cool down during the night, thanks to their vast metabolism. And some species have really become warm-blooded. This feature allowed them to remain active around the clock. Thus, the reptiles got a head start in obtaining food. It has also been found that dinosaurs had secondary breathing. This process occurred due to air sacs, which were special lung growths. Dinosaurs received oxygen from the atmosphere during inhalation and from oxygen bags during exhalation. Such a respiratory system turned out to be indispensable in the oxygen-poor Triassic period. Initially, the concentration of O2 in the atmosphere was 10 to 15%. At the end of the Triassic, the figure jumped to about 19%, but that still wasn't enough. To put this in perspective, oxygen makes up just over 21% of the current atmosphere, and in the Carboniferous period, it rose up to 35%. It's also important that dinosaur skin is scaly and water repellent. It protected animals from moisture loss and predators. Finally, dinosaur eggs were thick-shelled. Due to this, the cub's survival rate was rather high compared to other reptiles. However, the first reptiles still had an insanely difficult time in the harsh world of the Triassic. They were constantly fighting to the death for their place in the sun. Perhaps this is how dinosaurs survived alongside other Triassic inhabitants in what is now South Carolina. 200 million years ago, the rainy season could last 9 months and small lakes turned into vast water bodies. Naturally, water always attracts a lot of animals that can drink and hunt nearby. In ancient times, huge 5-meter Crocodile lemurs also loved to splash in the ponds looking for a suitable lunch. They were probably well fed, as there were plenty of fish and small reptiles to snack on during the rainy season. Carnivorous dinosaurs, such as the huge Garchiosaurus or Godzilla lizard, could also come to the drinking place. The largest of them in the Triassic were over 5 meters long and weighed 150 kilograms. These reptiles probably hunted numerous small animals near water bodies. Herds of herbivorous dinosaurs could graze in forests covered with lushy greenery near rivers and lakes. In millions of years, their descendants, sauropods, will grow 10-meter necks and huge bodies weighing dozens of tons. So far, the sizes of these animals, for example, the Rheahaceras, were much more modest. But some of them in the Triassic were already 10 meters long. Such reptiles still had elongated legs and not column-shaped as later. But they were able to rise on their hind limbs in order to reach the young leaves on the treetops. And they already had a steady barrel-shaped body. Small reptiles could also live among the forest trees. Many of them were bipedal during the Triassic period. For instance, Eroraptorians. They were usually no longer than 1 meter and weighed 10 kilograms. These nimble predators successfully hunted small reptiles and amphibians, grabbing insects on the fly. They also looked for and crushed the eggs of other dinosaurs with their sharp teeth. In addition, small predators often hunted in packs, so they could well have attacked a baby of huge dinosaurs. Interestingly, many of them were omnivores and didn't mind eating some plants for dessert. Meanwhile, cytodonts, the ancestors of future mammals, probably stayed in burrows during the day guarding their offspring. Some of their species, such as Synonithus, were already quite large. These animals were the size of a large dog, had wide jaws and sharp teeth. They could clearly stand for themselves. However, they probably preferred to go hunting only after dark to avoid huge predators. Cynogenates were warm-blooded, so the night cold wasn't much of a problem. In a nutshell, all the animals were well fed and satisfied during the rainy season. But water bodies would become shallow after the rainy season, leaving only a few fish alive. There would be fewer amphibians near the shores, too. Voracious crocodilomorphs would find it difficult to feed themselves under such conditions. However, predators could always count on some careless young reptile to stray from a flock of small dinosaurs at the drinking place. A strong big-mouth crocodilomorph armed with sharp teeth had every chance of getting it for dinner. Large dinosaurs, such as Godzilla, may also have considered smaller dinosaurs as prey. It can be assumed that small dinosaurs, like the airaptors, didn't starve themselves. After all, a lot of amphibians and insects could be found near the water bodies. Herds of huge herbivorous dinosaurs must have had a particularly difficult time. Tree-like plants would dry up completely during the rainless season. The lack of resources may have forced giants like Rheos to migrate in search of remaining forests. Moreover, they had a great chance to successfully make long transitions. Spikes and plates on animal skin protected their body from moisture loss. Perhaps, when the drought became completely unbearable, large predators began to hunt each other. If a crocodilomorph and a large predatory dinosaur had a fight, the latter would surely win. According to paleontologists, ancient reptiles were more mobile than crocodilomorphs. In addition, they often ate carrion in the forest. Smaller predators would probably get some leftovers after the bloody feast of these at the top of the food chain. With the onset of the rainy season, the animals that survived the drought, predominantly dinosaurs, returned to normal life near lakes and rivers. They went about their business foraging and laying eggs. This is how the dinosaurs became stronger on the planet. But it was most likely another global catastrophe that made them thrive. The Triassic-Jurassic extinction occurred 169 million years ago. Scientists don't have a single hypothesis on what caused it. Perhaps volcanoes contributed to dinosaurs thriving. The breakup of the Pangaea supercontinent led to intense volcanic eruptions. Numerous eruptions have caused huge amounts of carbon dioxide to be dumped into the atmosphere. They created a greenhouse effect and a dramatic climate change. And such changes are usually followed by ecosystem collapse. However, the cause of extinction may not have been connected to a global catastrophe. Some scientists believe it could be caused by cooling on the planet in the late Triassic. Polar and high mountain ice caps appeared that cooled the Earth even more. This led to the Ice Age and significant freezing of the ocean. Such a sharp change in climate caused another global extinction. It is also believed that a huge asteroid collided with our planet, leading to a disaster. However, the crater from the impact hasn't been found. However, over millions of years, it could have been wiped out by the ocean. In any case, about 50% of land animals died at the end of the Triassic. Many ecological niches became free after that. Dinosaurs were able to take them, further reinforcing their positions in the evolutionary landscape of the Earth.